Hello everyone, welcome back to this amazing platform of TUTOR learning. We are live again. So welcome back to this amazing platform, right? So I have been out from these classes of the integrals for a long time, and now we are back again with these sessions on integrals, right? So welcome back all of you. Okay. So before we start these classes, a quick announcement for all of you is that we are starting with the other batches, especially for the JEE upcoming 2022 examination. Okay. And the price is starting just at rupees 199. 1,999, okay, just less than 2,000, okay. So if you want to get the seats or if you want to get live classes and you want to be enrolled in those coaching classes, then definitely contact us on this particular number that is mentioned in your live chat, okay. For your help, I'm also basically writing the number over here. So if you want to get personalized contact and doubt clearance, you can contact us on this particular number. To start enrolling for this batch, you can always call us on this particular number. Okay, so the batches are going to start very soon. So please enroll as soon as possible. Okay. Okay, so let's start the integrals. Okay, so we have been discussing about the integrals, and if you haven't watched the integral session, then you are basically missing out on a lot of things, right? So as far of the session that I have taken so far on integrals, I have basically discussed about the different methods of solution of indefinite integrals, right? So if you have watched those particular sessions, and I hope you have must have, because if you're watching this part 12 of this particular integral, you must have finished watching up all the integral sessions and even the lectures that I have taken so far before, right? So in this today's session, I'm going to discuss about some special integrals, and especially as of the previous class, we have discussed a lot of different special integrals and derived substitution as well, right? So in today's class, we're going to discuss about some of the special substitutions or special classes of integrals. Along with that, I'm also going to talk about a special form of trigonometric integral and a special form of algebraic integral expression, right? Now that is very, very important, because if you look at the J advanced questions, you can find that those types of questions has been asked like a lot of times, okay? So that basically makes that particular type of question really, really important. Okay. So let's not talk a lot. Let's start directly. Okay. So before we start, just a quick note. If you're watching the session, you have to watch the previous sessions as well, because if you don't watch the previous session, you won't be able to understand the concepts over here. So in order to watch the sessions of integrals, you can always check out our channel. And if you're new to this particular platform, please like the video and subscribe the channel, and also share this video among your friends, your relatives, anyways, who are preparing for the upcoming JEE mains and advanced examination, and also whose examination has this concept of integrals as well. So with this all due, let's get started. Okay, so today I'm going to first of all start with integrals integrals of the form. Okay, integrals of the special form, that is, so as in the last class we have been discussing about some irrational type of integrals. So let us say I have an integral like dx upon x minus k whole to the power r, and then we have square root of, then I have square root of ax square plus bx plus c. Okay, so let us say I have this kind of integral, right? And also to note that this particular value of r is greater than or equal to 2, and also the r value belongs to an integer number. Okay, it also belongs to an integer. So if we have this particular condition over here, and let us say I want to evaluate that what is the solution of this particular integral, right? Now how to approach this question of integral, let's try to understand over here, right? So this question of integral is very, very simple. What we have to do is we just have to simply do one step of substitution, that is, and the substitution over here, if you recall. Okay, so this is something that you need to know, and if you don't know, you won't have no clue while you're solving in the exam. So the simple substitution over here is that you have to substitute x minus k as sum 1 upon t. Okay, x minus k as sum 1 upon t. So if you do that, if you do this, then you can solve this question very, very easily. And why do we need to do the substitution? You will get to know once we solve some questions. Okay, so let's say I take an example to basically illustrate what is the special form of this integral, right? So let us say I have an integral. So let us say I have an integral given in the question as integration of dx upon x minus 3 whole to the power 3, and then square root of, and then I have square root of x square minus 6x plus 10, x square minus 6x plus 10. Okay, so this is what you have to basically given as the integral, right? So let's say how we basically need to get this integral, right? So in order to solve this integral, let us try to use that whatever we have learned. So whenever you look at this kinds of integral where we have a linear expression whole to the power something and some integer quantity, and then we have a square root term of quadratic, then the simple way to solve this question. So if I just try to solve this question, the solution of the question, let's start with, let us substitute x minus 3 over here. Let's substitute x minus 3 over here as some variable 1 upon t. Right. So if you do this assumption, then the easy part is that if we differentiate both the side, it is dx is equals to minus 1 upon t square dt. Dx is equal to minus 1 upon t square dt. Okay. So then our question is very, very simple after we do this particular substitution over here. So let's see how we can get this solution over here. So if I do the substitution, then my integral will be now of the form of, so in place of dx, I can write it as minus 1 upon t square dt and whole divided by, now x minus 3 whole cube will be like 1 upon t whole cube, right? And similarly, now the important part over here is to basically understand how we can represent this particular quadratic in terms of x minus 3, right? So that is another very important job. So another easy thing is basically we can write x is equals to 1 upon t plus 3, 1 upon t plus 3. Now if you do the substitution over here, then it is going to be square root of t plus 1 upon 3 whole square minus 6 times of t plus 1 upon 3, and then we have plus 10, and then we have plus 10 over here, right? So if we look at this form of integral, then the simple way to solve is just do the individual division over here, right? So if you do this, then your integral will be equals to, just, so this is t cube in the denominator. So this particular thing is basically like and then denominator we have t square. So this goes in the numerator and the t square goes in the denominator. So we will have ultimately have t over there, right? So this form, and if you just simplify this particular expression and then you take another t common, so you will feel that there will be like t square dt whole divided by t square dt. Okay, I didn't make a mistake over here. So this should be like 1 upon t, right? Not 1 upon 3. I didn't make a mistake over here, right? Sorry for it. Okay, I hope you can correct this step. So it's 1 upon t plus 3. Okay, great. So now if from here, if you just take 1 upon t whole square or 1 upon t whole square is common, if you take 1 upon t whole square is common, then the initial part that you left out with is like t square, and don't forget there is a minus sign, and also we will have square root of 1 plus t square. Now this difficult form of integral is now simplified. It's just a simple algebraic form of integral, right? Which is much simpler to do it. So what we can do over here is that we can try to simplify this integral by evaluating in form of, like, we can write this minus t as 1 minus, so 1 plus t square. Okay, so 1 plus t square, and then so also, okay, so what I'm trying to do over here is that I can write this expression over here as 1 minus 1 plus t square, right? So I can write this expression as 1 minus 1 plus t square and then whole divided by square root of 1 plus t square dt. Right, so this is our integral over here. Now if we solve this question and then individually if we do the integration and division, so this is the first integral will be like dt upon square root of 1 plus t square, and then minus 1 plus t square and square root of that, and integration with respect to dt. So this is the simple integration we will have now, right? So therefore the solution of this particular integral is going to be very simple. It is going to be natural log of t plus square root of 1 plus t square, right? T plus square root of 1 plus t square minus, and this integration is very simple. It is basically going to be half times square root of 1 plus t square minus half times sorry, half times natural log of mod of t plus square root of 1 plus t square, and then we have a constant c over here. So this is the final form of the solution of the integral question. I hope this question is clear to all of you. I hope this question of the integral is clear to all of you. So this is one of the special form of integral. So whenever you encounter this kind of form of integral, please make sure that you apply the following results and you get to the solution as follows. Okay. So please keep this in mind because it's going to be really, really useful and helpful, especially for the examination. Okay. So you make sure that you complete this form of integrals before you go for your actual examination. Okay. I hope this is clear to all of you. Is this clear to all of you? Okay, please let me know. I'm just going through a live chat. Please let me know. Please let me know. Okay, so I see no questions in live chat. So that basically makes you that this concept is clear to all of you. All right. So I hope this concept is clear. So let us try to learn another general form of this kind of integral. Okay. 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 So let us say I have a form of integral. So let us look at another form of integral. Okay. So let's see how we proceed for another form of integral. So let us say whenever you have this kind of form of integral, let us say the integral form is you have some quadratic ax square plus bx, ax square plus bx plus c. Okay, and then whole divided by dx plus e, and then we have square root of another quadratic. Okay, so whenever you have this form of integral, let us say you have this particular form of integral, and how we try to solve this result. Okay, so this is the general form of this indefinite, like irrational kind of integral that you can try to get in examination. Okay, so how we proceed with the solution is very simple. So in order to solve this form of general form of integrals, you have to keep something in mind. That is a simple thing is that whatever a quadratic is given in the numerator, you have to take that quadratic and have to express in some form of the linear term over here and some form of the derivative of this quadratic term in the square root part, right? So are we going to do that? So first of all we have to do like some coefficient a1 times dx plus e multiplied with now differential derivative of this under square root of this quadratic term which is present inside the square root. So this is going to be like 2 fx plus g, right? And then some b1 times will have dx plus e and then some c1. Okay, then some c1. Okay, then we have some C1 over here, right? So this A1, B1 and C1 are basically some constant which are obtained by comparing the coefficient on both the sides, right? So how do we solve this question is very simple. You just have to first of all remember this following step. So whenever you have a quadratic upon the linear term and divided by square root of another quadratic, so this form of integral. So in order to solve this form of integral, how do we do solve for this is basically quite simple. So you have to just remember this following step that you have to represent this quadratic term over here in terms of this following notation over here, right? Now once we do that, we have to compare the coefficient in order to get the coefficient constants a1, b1 and c1, right? So I hope this step is clear to all of you, right? So let us try to solve one question or one example based on this following form over here, right? So let us see one example over here. Let's say I have a given integration that is integration of 2x squared plus 5x plus 9, 2x squared plus 5x plus 9 dx whole divided by x plus 1 whole divided by x plus 1, and then we have sorry, and then we have square root of x squared plus x plus 1, right? and then we have square root of x square plus x plus 1, right? So how do we solve this question? Okay, so if you're watching this particular session, please try to solve this question. Okay, please try to uh, express the numerator in form of this particular expression. Okay, and try to get me the values of the constant a1, b1, and c1. Okay, so if you do that, so please try to solve that part over here, okay, and try to get the constant values of a1, b1, and c1, okay. Then I will tell you that how you can proceed with the question, okay, because after you get to the constants a1, b1, and c1, the question is very simple, and you just need to follow some methods of the simple principles, and then we do the substitution and we get the results, okay. So that is what we will try to do over here. So let's see how we can proceed with the solution. So please let me know. So try to get the values of a1, b1, and c1. Okay, so I hope you are trying to get the values of the constants. Okay, the step is very simple. You just need to express the quadratic that is present in the numerator, in terms of the follows. So we will write it as a times of, x1 plus x plus 1, and then we will write it as 2x plus 1, right? Plus b times of, the same thing, that is x plus 1 plus some c, right? Now we just compare the coefficient. Let us just simplify this expression and we'll solve this coefficient values, okay? And we solve for this coefficient value. So we will have, first of all, so if we solve the coefficient of x square, it will be like 2 times of a, and then for coefficient of x it will be 3a plus b, and then we'll have a plus b plus c as a coefficient of the constant, right? So we just compare it. So on comparing, you'll get the value of a as 1, you'll get the value of b as equals to 2, and you will get the value of c as equals to 6. Okay, so these are the following values of the constant, right? So once you have found out this constant, now the solution is very simple. So let's see how I'm basically talking it simple, is that you have represented this particular quadratic over here in terms of this follow, such that I can cancel out the linear terms and I can make it simply in form of a substitution question. Okay, a simple question of substitution. So therefore, your integral is now a simple integration of x plus 1, multiplied with 2x plus 1 divided by square root of x plus x square plus x plus 1, and also we have a linear term x plus 1 over here, right? This is the first form of the integral, where I'm taking this part and divided by this common part over here, plus the other form of integral, that is 2 times of x plus 1 divided by x plus 1, and then square root of x square plus x plus 1. Okay, so and then the last part, which is 6 times of 1 upon square root of x square plus x plus 1, okay, x square plus x plus 1 dx, okay. So this is the form of the integral, which is now simplified over here. So therefore the easy part is that we can cancel out the linear terms, and the question is simply a question of simple question, right, which you have learned in while you were solving the questions of special integrals, and also when you were solving questions of integration by substitution, right? So with this, let us try to see what is solution. So if you just try to solve it, and I'm directly writing the final answer over here, because I know you can solve it from here directly. Okay, so please do these lines of calculation over here, and the final solution will look something like 2 times of square root of x square plus 1 plus 2 times of natural log of mod of x plus 2, x plus 1 upon 2, plus square root of x square plus x plus 1, and then minus we will have minus 6 times of natural log of 1 minus x plus square root of x square plus x plus 1, and then whole divided by 2 times of x plus 1, and plus some constant c. So this is going to be the final solution of this particular question over here, right? So I know this is a very long question, but this is something very important, because if you don't know this particular form of solution methods, then you won't be able to solve the question. Okay, so with this, let us try to now move to the integration of the third type. And the third type of integral that we will discuss in the today's session, or a type 3 integral that we discuss in today's session, is basically when we have integration of the form of sine to the power mx and we have cos to the power nx. Okay, when we have sine to the power mx and cos to the power nx, this form of integral, right? So whenever we have this form of integral, how do we solve this question? Okay, so let's see how do we solve this question. And before we proceed, here both n and m are belonging to natural number. Here both n and m are belongs to natural number. Okay, so both n and m actually belongs to the natural number, right? Now the method to solve this question, now this is something that you will learn, something called as the Wallis formula. Okay, but I am basically trying to give you the Wallis formula only for the definite integral. So when we discuss about the definite integral, we're definitely going to discuss about it. But let's say you have this form of integral, how we solve this integral of indefinite integrals, right? So in order to solve this, there are certain theorems that you need to understand, or certain principles that you need to keep in mind, that if one of the powers, so whenever you have this integral, just check for this following. Okay, so if one of the if one of the power is odd. Okay, so if you have one of the power as odd, so if you have either of m or n as an odd power, then you have to substitute either of them. Okay, so then you have to substitute either of them. So substitute some cos sin x as a t or cos x some t. Okay, so you can substitute either of them. Okay, substitute either of them. Okay, so this is how you have to solve it. Okay, now what if you get both are even? Okay, so this is for the case only when one of the power is odd. Okay, now if both are even, both power are even. Okay, if you have both the powers as an even power. Okay, so what we'll do if you have both the powers as even power? Okay, so when we have both power as even power, we'll just use trigonometric identities. Okay, trigonometric identities like sine square x plus cos square x is equal to 1, those kinds of identities. Okay, so when we have this kinds of form of integral, we'll just use trigonometric identities. Okay, so we just use trigonometric identities. Okay, and the last case comes in when if m and n are rational. Okay, if m and n are rational, now first of all I was talking about when n and m was belongs to natural number. Okay, so if m and n are rational number, okay, are rational, and m plus n minus 2 divided by 2, okay, minus 2, and then we have divided by 2. Okay, so if m and n are rational and m plus n minus 2 divided by 2 is a negative integer, okay, is a negative integer, then the substitution is very different substitution. So that is basically you have to substitute. Okay, so when you have this form of the solution, then you substitute simply your cot x as some as some variable p. Okay, you have to substitute cot x as some p, or maybe or or maybe or maybe substitute tan x as some p. Okay, so you have to substitute either cot x as p or tan x as p. So whenever you have this form of integral, please make sure that you ensure that these following conditions are satisfied or not. Okay, before you are doing for any kind of substitution in the question. Okay, so let's see one of the examples. Okay, now the fourth part is basically different from the first two parts. So this is basically the first two part is only valid only in the case when both m and n are natural numbers, right? So if you have both m and n are rational and m plus n minus 2 by 2 is a negative integer, then only you will substitute this following. Okay, so please make sure the third note over here, because that is very important. Okay, so let us try to solve one example problem based on this particular form of integral, right? So let us say I have to integrate, let us say I have to integrate sine to the power 3x and cos to the power 5x. Okay, so if we have to integrate this form of integral, how do we solve for this question? Okay, so if you look at the power, both the powers are basically rational natural number and natural number, and both of the power are basically odd. So if any one of the power are odd, then also what we will do is basically we will substitute either of the follows. So let us substitute that cos x as some t. Okay, so in order to solve this question, we'll first of all assume cos x as t. Okay, so first of all, we'll assume cos x as t, and once we do this following assumption, your minus sin x dx is going to be equal to dt. So minus sin x dx is going to be equal to dt. So therefore, the solution from this question over here is going to be like, so if we take one sine common out of it, so this is going to be sine square into sine, that is basically sin x in dx is going to dt, and then sine square, I can write sine square x as 1 minus cos square x. So that will be basically 1 minus t square, and then we have t to the power 5, and then we have minus of dt over here. I hope this solution is clear, right? So therefore, the solution is very, very simple. It is basically t to the power 7, it is basically integration of t to the power 7 dt minus t to the power 7 dt minus over here we will have t square, sorry, t to the power 5, t to the power 5 dt, and then we have over here, so t to the power 5 dt, and that's all, right? Oh yeah, that's all, right? So the solution is very, very simple. It is going to be t to the power 8 divided by 8, t to the power 8 divided by 8 minus t to the power 5 divided by 5. Okay, t to the power 5 divided by 5, and the solution or the result of this integral, because t we assumed as cos, right? So cos to the power 8x divided by 8 minus cos to the power 5x divided by, oh sorry, this should be 6. Okay, so sorry, this should be 6. So cos to the power 6x divided by 6 and plus some constant c. So this is going to be the solution of this problem. Okay, so if you have understood these particular problems, I hope there will be not an issue in order to solve any other types of question. Okay, so I will leave, I will do one job. I will leave some question as a homework to practice in the upcoming classes. Okay, so let us say I give you some homework. Okay, so let me give some homework. So the first question that I want to give you as homework is that please try to solve this following integral. So if you have integral of the form sine to the power 11 by 3x multiplied with cos to the power minus of 1 by 3x. Okay, so please try to solve this first problem, which is also the type 3 integral. And the second problem that I'm giving is quite bit different, and it's not like an easy problem, but I would say please try to think your brain on it, okay, and try to simplify. Okay, so this question is dx upon 2 times of sine x plus some secant x. Okay, plus some secant x. So this is an interesting question, and please try to solve this question. Okay, please try to solve this two question, because if you try to solve this last second question, you will get to know and learn a lot as well, right? So please make sure that you try to solve this question. If you're not getting the solution, I'm definitely going to discuss the solution for this question. Okay, so this is more important than the question number first, because for question number one, you basically have the predefined methods that you basically have to apply. But for question number second, you have to first of all make it as a form so that you can apply your following formulas, right? So please let me know if you have any questions. Any questions, anyone? Pratham Shahu, which IIT, which brand? How do you think you are learned enough to teach? Hi, read my comment. Pratham Shahu, I hope you can read my qualifications, okay? And I think if you want to study, you can study. Otherwise, you just go and get another contents, okay? I don't think that there is someone to be judged, okay? Because the platform I'm basically working on, and they have quite judged my qualification. So they basically based on the qualification, they have quite given me this chance, okay? So I don't think I need to prove you to basically be enough to teach you, okay? So if you don't like to be in these classes, you can just leave. And thanks for adding some minutes to my watch time, okay? And also, please share this channel videos among to your friends as well, okay? So that at least your friends who wants to learn, at least they can learn as well, okay? Okay. Any questions? Any questions regarding this these problems over here? Okay. Please let me know any questions if you have regarding these problems over here, because other things are all good. Okay. We can also talk about those things later as well. Hi Kartik Sharma. Hi. No sir. Which part is not clear? Kartik Sharma, एक बार बता सकते हो कौन सा part clear नहीं हुआ? एक बार बताओ तो मैं help करने की कोशिश करूंगा. Hi sir. हाँ कार्तिक शर्मा बताओ. Which part is not clear कार्तिक शर्मा? कौन सा part में दिक्कत आ रहा है? कार्तिक बताओ. ऑल इज क्लियर सर. ओके ठीक है कार्तिक शर्मा, अगर सब क्लियर हो चुका है, ये दो क्वेश्चन होमवर्क में कर लेना, ठीक है? प्लीज ये दो क्वेश्चन होमवर्क में करके मुझे नेक्स्ट क्लास में बताना, ठीक है? आई वुड लव टू डिस्कस द सॉल्यूशन ऑफ द सेकंड वन, बट एक बार खुद से भी ट्राई करना, ठीक है? ओके, सो ऑल थिंग्स इज क्लियर, एंड देन लेट्स मूव टू द other type 4 types of integral. Okay, type 4 form of integral. So what is the type 4 form of integral? So whenever you have integral which is of the form x to the power m, and then we have a plus bx, a plus bx whole to the power n, sorry, a plus bx to the power n, and then whole to the power p. Okay, now this is a very special form of integral. Okay, whole to the power p. Okay, now this form of integral is very special. Okay, now in order to solve this question, you have to basically learn about the binomial expansion first of all, and secondly, there are a lot of checks that you have basically find out that before you go for the actual solutions problem. So there are multiple cases that you need to understand before you go for the actual solution of this problem. Okay, so the case one that you need to understand. So the case one, if you have p which is a natural number, if you have p which is a natural number, we just simply use the binomial expansion. Okay, we just simply use binomial. Okay, we just simply use binomial. Okay, so if whenever you have this p as a natural number, just try to use binomial and then integrate. Okay, so whenever you have this form, just try to use binomial and then just integrate. Okay, and then just integrate. The question is very simple. Okay, let's talk about the case 2. So let's talk about the case 2. So the case 2, in the case 2, if I have my p which belongs to negative integer, if I have p which belongs to negative integer, the step that you need to perform over here is that you have to just assume x as some t to the power k, x as some t to the power k, where your k is basically nothing but the LCM of, where your k is basically nothing but the LCM of m and n. Okay, LCM of m and n. So out of this k is basically the lowest common factor. Okay, or lowest common mean either of m or n. So this is the second case. So whenever you have p which belongs to the negative integer, then you just have to assume just by do the substitution over here, that is x equals to t to the power k. Okay. Now for third case, what will arrive over here? Third case over here that we will arrive, that is basically when you have m plus 1 by 2, if m plus 1 by 2 belongs to an integer. Okay, so when we have m plus 1 by 2 belongs to an integer, and p is basically a fraction. Okay, and your p is basically a fraction. If your p is basically a fraction, then you just need to assume a plus x to the power n, a plus x to the power n as equals to t to the power k and x to the power n. Okay, so we put this a plus b x to the power n as t to the power k into x to the power n, where k is the denominator. Okay, denominator of fraction. Uh, okay, my bad. Okay, so I was basically going too far. So first of all, you have to first of all assume this. There is t to the power k over here. Okay, t to the power k over here, because just simple t to the power k, where you have m plus 1 by n as an integer. Okay, now that is for a different case. Okay, so what I was writing down is for a different case. So if you just assume this as t to the power k, where k is the denominator, of this fraction. So for example, you have p as some fraction. Okay, so let's say some s upon k. Okay, so this denominator of this fraction is basically this k over here. Okay, so it is just the denominator. So it is just the denominator of the fraction m, of the fraction p. Okay, of the fraction p. Okay, so this is our third case, and the last and final case, or the fourth and the final case, is that whenever you have this m plus 1 upon 2 plus some p as some integer. So whenever this quantity belongs to an integer, so sometimes it might happen that p m plus 1 by 2 is not an integer. So how do we solve for this question? So then you have to check that m plus 1 by 2 plus some p is an integer or not. Okay, then if you find out this is an integer and p belongs to a fraction, okay, p belongs to some fraction, okay, p belongs to some fraction, so then in order to solve this question, we put this a plus b x to the power n, a plus b x to the power n as some t to the power k into x to the power n, where k is again the denominator of this particular fraction p. Okay, so this is how you have to solve for these kinds of problems. Okay, so let us try to see one simple example to basically illustrate what I was basically talking about, right? So let me take one simple example to illustrate. Okay, because I don't want to make things very complicated at the beginning. Okay, so let us try to solve a simple example problem. Okay, before we solve the example one, please let me know if you have any questions so that I can discuss about this question. Which is our next topic? Our next topic is going to be definite integral. Okay, and after we finish definite integral, it's going to be area under the curve. ओके कार्तिक शर्मा, समझ में आता है? कार्तिक शर्मा, इज इट क्लियर? अगर तुम्हारा कोई रिकमेंडेशन हो डेफिनेटली बताओ, मैं देन आई विल ट्राई टू टेक दैट टॉपिक एज वेल। ओके, अगर तुम्हारा कुछ रिकमेंडेशन हो डेफिनेटली मुझे बताओ, ताकि मैं वो भी टॉपिक से भी डिस्कस कर रहा हूँ, ठीक है? ओके। Okay, so let us try to solve one problem before we go for any other things. So the question is very simple. The question is very simple. We just have to integrate. We just have to integrate x to the power minus 11, and then we have 1 plus x to the power 4 whole to the power minus 1 upon 2. Okay, and then we have dx. So if you look at this problem over here, your n is a negative integer and your p is basically a fraction. So whenever you see p is a fraction, first of all you have to check that what is your result for m plus 1 by n. Okay, okay, I just made a terrible mistake over here. It should be m plus 1 upon n. Okay, m plus 1 upon n over here. Okay, and also please correct it. Okay, please correct it. This should be also be n over here. Okay, this should not be 2. This should also be n over here. Okay, n, just simple n, right? So whenever you have this form, so first of all, you have to check and evaluate that whether the value of m plus 1 upon 2 is an even integer or not. Okay, so if I check the value of m plus 1 upon 2, that is gonna be a fraction. So therefore, let us now add the p as well to check whether it is a integer or not. And if you do that, you're going to get as minus 11 plus 1 upon 4. So this should be n over here. Again, I made a mistake. So please pardon me. Okay, so please pardon me. And this should be n over here. So the 4 over here plus minus of 1 upon 2. So if you just evaluate this result, this result is going to be simply equal to minus 3, which is an integer. Okay, which is an integer. So therefore, what we have to assume is that 1 plus x to the power 4, 1 plus x to the power 4 has some t to the power k, where k is basically the denominator of the fraction. So that is basically 2, and then we have x to the power, and then we have x to the power n, right? X to the power n, which is basically in the question is basically mentioned as 4. So if I do the substitution over here, let's do the substitution and then basically try to go for it. So if I divide x to the power 4, I'm going to get 1 upon x to the power 4 plus 1, right? 1 upon x to the power 4 plus 1, which is equal to t square. So if I differentiate both the sides, so now if I differentiate both the sides and try to do this question by substitution, the result is going to be minus 4 upon x to the power 5 dx is equals to dt, right? So we will have this form of the result, right? So we will have this form of result, and therefore now your integral is much simpler. So now your integral is much simpler. So now your integral looks like dx upon x to the power 11. Then we have like um, 1 plus x to the power 4. So if I take x to the power, if I take another x square as common out of it, okay, because if I take x square common and out of the square root, it will be x square. So therefore, in the denominator, I already had mine 11 in x to the power 11. So, and then again, x square is coming out. So it's going to be x to the power 13. X to the power 13 over here. And then the left part is 1 plus 1 upon x whole to the power 1 upon 2, right? Which is basically very simple to solve this question. The question is simply in terms that we can write a simple expression over here as minus 1 upon 4. So what I'm going to do over here is that again, I'm assuming 1 plus, so this assumption, so then I've done this assumption now, this particular form is going to be like equals to minus of 1 upon 4, minus of 1 upon 4 integration of 2t dt whole divided by x to the power 5, sorry, x to the power 8 it is going to be, because I've taken only 5 from 13, so it's going to be x to the power 8, and then the remaining part is again t, and the remaining part is your t and t get cancelled, and therefore the result you're going to get the solution over here. And also you can find the value of x in terms of t as well from this equation, and if you just put it over here, the result is going to be like, minus 1 upon 2 integration of t square minus 1, integration of t square minus 1, okay, integration of t square minus 1 whole cube dt, which is equals to minus 1 upon 2 integration of t to the power 4 minus 2t square plus of 1. Okay, so okay, I don't make a mistake, so we square over here, right? We square over here, right? Great. Great. So once we have this result, so this is the integration of this result, which is dt. And if I solve this integral, if I just solve this integral over here, the integral answer is going to be simply like minus 1 upon 2 t to the power 5 upon 5 minus 2t cube upon 3 plus some t over here. This is going to be the solution of this particular result. I hope this result is clear to all of you. Okay. So with this, I come to the end of all my discussion of special integral. So the next class is going to be on the reduction formula, and also in the next class we're going to start about the definite integral. Okay. So we are also going to start definite integral soon in our next class. Okay. I hope you are all excited for the definite integrals part. Okay, so let us keep our class till here over here, and I wish we will solve this homework problem that I already mentioned in the previous previous topic, previous discussion. Okay, these discussions as well, right? So please solve these homework problems and let me know the solution, or let me know the answer to the homework problem in the comment section after the live class is over. Okay, so with this, I thank you all of you for joining this particular session on live and watching session. Okay, so please try to watch the session carefully, try to understand each and every word so that you can make the best out of these particular sessions. Okay, so with this, I will take a leave now, and I wish you all the best for the upcoming examination, and keep preparing, keep working hard.